Okay, so here is a regular u substitution. So let's just go practice it again. So I'm going to let u equal the inside function. That's the general rule for u substitution. So take the derivative, so I get 3dx. So I notice there's no 3, so I'm going to multiply both sides by 1/3. So now I've got the square root of u, and then I'm going to replace dx with 1/3 du. And I want to make sure that you're really clear on how to change the limits of integration. So if I take x equals 0 and I put it into the conversion factor of 4 plus 3x, I get u equal 4. So if I take x equals 7 and I put it into this conversion factor, then I get u equals 7 times 3 is 21 plus 4 is 25. All right, so I'm going to put the 4 here and the 25, right? So the 0 gets replaced with the 4 and the 7 gets replaced with the 25. So I'm going to take the time to pull the 1/3 outside, rewrite it as u to the 1/2. And now remember, since I changed the limits of the integration, I'm never going to go back to x's. So I get 1/3, so I add 1 to the exponent, so I get 3/2 over 3/2, or times 2/3, and then 4 to 25. So that gives me 2/9, so I'm putting 25 in. So 25 to the 3/2, subtract 4 to the 3/2. And we should know what those are, right? So this is the square root of 25, which is 5, and then cube it, so that's 125, subtract the square root of 4, which is 2, and cube it. So, and I'll just leave it like that. But I do want you to, if they're nice numbers, deal with the fractional exponents. Okay, so here's where I'm going to call clever u substitution. So we had, so now I'm going to say, let's start off what we usually do, and let's let u equal 9 plus x. So the derivative, you know the derivative of x is just 1 dx. So if I start, and I'm just going to rewrite this, 9 plus x dx, just separating everything out. So this will turn into the square root of u. Dx can get replaced with du. Then I have the quandary of what am I going to do with this x? So it all comes back to this conversion factor here. So can I do something here to substitute in for x to get it in terms of u's? Yes, I can. So I can say u minus 9 is equal to x. So replace this with u minus 9. Okay, so I still have these limits of integration to take care of. So I'm going to put x equals 0 into this conversion factor. So I get u equal 9. If I put x equals 7 into this conversion factor, I get u equals 16. So 9 to 16. Okay, so in order to take this antiderivative, I'm going to need to multiply this out. So I'm going to multiply these two terms. So this is u to the 1/2 times u to the 1, and you know you add exponents, right? So 1/2 plus 1 gives me u to the 3/2. Minus, and if I multiply this, I get minus 9 u to the 1/2. Now I'm ready to take the antiderivative. So if I add 1, so I get u to the 5/2 over 5/2, or times 2/5, minus, carry the 9, add 1 to the exponent of this, so I get u to the 3/2 over 3/2, or times 2/3. And I'm going to evaluate it between 9 and 16. So 2/5, so I'll have 16 to the 5/2 minus 18, oh, I guess I should fix that, right? So this is 6, right? Because cancel the 3's. Then I get 16 to the 3/2. Then I'm going to subtract off, hold on a second, I made a mistake here. Hold the fort. Okay, so this 2/5 is just times this number here. And then minus 6, and if I put the 16 in, 16 to the 3/2. Okay, so that's all for the top limit, right? Now I'm going to subtract off, plugging in the bottom limit. So put the 9 in to both places. So 9 to the 5/2 minus 6, 9 to the 3/2. All right, So let's play with this a little bit. So I have 2/5. So I have 16, square root of 16 is 4. I'm just going to leave it as 4 to the 5th minus 6. And then here, square root of 16 is 4, cubed is 64. Subtract 2/9, and then square root of 9 is 3 cubed, or sorry, 3 to the 5th power. I'll just leave it like that. These two negatives make a positive, and I'm going to take the square root of 9 and get 3 cubed, which is 27. All right, I'm just going to leave it like this. So it's a little, just use a calculator to get a little bit more simplified, what you would find in your homework answers. Nice and ugly, right? So when we have limits of integration, it can be ugly. This one, indefinite integral, no limits of integration, so we just get to put the plus c at the end, and that's nice. We like that much better. All right, so this one here, I'm looking at this e to the 2x in the numerator. Something different is going to happen here. Here, I'm going to let u equal 2 plus e to the x. The denominator, because there's no really inside function, so I'm going to use the denominator as the inside. Okay, so let's see what happens when I take the derivative. So the derivative is e to the x dx. Okay, so remember, I need to take this out in order to get this in. So I'm going to take my time. I'm going to rewrite e to the 2x as e to the x times e to the x. Okay, so let's think about that. So this e to the x here, and I'm just going to split these up. So I'm going to have this e to the x, I'm just going to write here. Then I'm going to write 1 over 2 plus e to the x, and then times e to the x dx. So if I take this e to the x dx out, I can put in du, right? Take this out, put du in. All right. Then I have 1 over u. That's my u right there. What am I going to do with e to the x? Back to the conversion factor. Go back to where your u substitution began. So if I solve for e to the x, I get u minus 2 is e to the x. So replace e to the x with u minus 2. All right, so let's see what we've got here. So u minus 2 over u du. No limits to change, that's nice. So what am I going to do here? Lots of good algebra can happen. I can split it up if I have an addition or the subtraction in the numerator. So I'm just going to go slow. So you see u over u minus 2 over u du. So u over u, that's just 1, right? So the integral of 1, well, let me just write it. So 1 minus 2 over u du. So the integral of 1 is, well, don't be careful you don't write x, because we're here in u land, right? So I've got du here. So the integral of 1 is u minus, and this is 2 times 1 over u, and the antiderivative of 1 over u is ln of u. Make sure you put the absolute value bars. The last step is to replace u with what it was in terms of x's. So I have 2 plus e to the x minus 2 ln of 2 plus e to the x plus c. So you have to put the absolute value bars, but once I think about it, this will always be positive, so they could be taken off. Nice, good, hard problem. All right, so another thing I want you to know is to be able to recognize, because it will be helpful for you, is to know when you have an odd function. So what an odd function means is if you replace x with negative x, you get negative f of x out. So let's just look at f of x equaling x cubed. So if I replace x with negative x, I get x cubed, but I get a negative 1 cubed, so that's negative x cubed, and that's the same thing as saying the opposite of the original function. That's what it means to be odd. And so if I take the antiderivative of this, I get x to the 4th over 4 between negative 2 and 2. Let's see what happens. So I get 1/4. I'll have 2 to the 4th, subtract negative 2 to the 4th. Wait a minute. 1/4 So 2 to the inside here, I'll have 2 to the 4th minus 2 to the 4th. That will give me 0. So remember what we did a long time ago. We talked about negative areas and positive areas, right? So if I'm talking between -2 and 2, this area here will be negative, remember, because it's below the x-axis. This area here will be positive, and they're the same area because it's symmetric. This is from -2 and +2. So when I have an odd function and it's going from the negative of the one number to the positive of the same number, I know the answer is going to be 0. No work needed. Okay, so when will you need to know this, or when will this be useful for you? Well, if you have an integral here, and I think there's no way this is going to work, I can't possibly take the antiderivative of that. No u substitution is going to work. Hey, wait a minute, is this an odd function? So I'm just going to ask that you would just show me that you verified it. So if I substitute in -x, then you know that sine of -x is negative sine of x. And then if I take -x to the 6th power, that makes it positive. So this truly is the opposite of the function, negative of the original function. So it's 0. And the same thing with this one. So tangent of -x, right? Substituting -x in. So this is the f of -x. So tangent is sine of -x over cosine of -x. So you know this is negative and this is positive. So this gives me the opposite of tangent. So that's the opposite of the function. Oops, I made a mistake here, didn't I? All right, let me start this one over again. I forgot the cubed. All right, so let's start over again. F of -x is tangent of -x cubed. So let me pull the cubed all the way on the outside, and then let's rewrite this as sine of -x, cosine of -x. So keeping the cubed all on the outside, this is negative sine of x, and this is positive cosine of x. These are two facts you need to know. So this is the same as saying negative tangent of x all cubed, and if it's a negative cubed, you get a negative tangent cubed. That is exactly negative of the function. So this is 0.